Hello, everyone, and pleased to welcome you in this session about choreography and orchestration. So today I'm with my colleague Mete, and I'm Guillaume Laforge. I'm a developer advocate for Google Cloud.
Hello, everyone. My name is Mete Atamel. I am also a developer advocate at Google, and I will be joining this session a little bit later.
So, as we said, we're going to speak about choreography and orchestration in serverless microservices or microservices in general. This is kind of an overview of this topic, but also lessons learned along the way as we built an application initially with an event-driven approach, and then later on rewrote it, introducing orchestration as well. So be sure to stay tuned till the end, where we show this concrete example where we learned along the way various things. So choreography and orchestration, by this, we're not speaking of that kind of choreography like ballet dancing or musical orchestra. Now we're going to speak about how microservices communicate together, how they can interact with each other, and we'll share with you the application we built at the end, where we applied those various principles. So if you take a simple e-commerce kind of transaction and application where you have multiple services and different technologies, here we're using App Engine, Cloud Run, Cloud Functions from Google Cloud. It doesn't matter which cloud or where you're hosting your services. Here we have on the left, we've got a front-end web application that is going to call a payment processor service. So it's pretty sequential. And once the payment is processed, like your credit card is charged, it's going to call a shipper service that's going to prepare the parcel for sending through some shipping service, and then a notification because you'd like to know when your parcel is going to be delivered at your place. So here it's pretty sequential, and each service is calling each, the next service as a sequence and in turn. So there's a pretty tight coupling between those services. So it's not ideal. If something fails, like payment processing or shipping, the rest of the transaction or the whole business process will actually fail. So it's not really ideal. You could also think of another approach where the front end would potentially serve as a kind of orchestrator, but we'll come back to that, where the front end calls each services in turn, but it's not necessarily ideal. And there's also a lot of coupling coming from the front end and the back end. So it's not necessarily great. But there are some advantages to such approaches. So let's list some pros and cons. So once you've split things from the monolith into several microservices, it's somewhat of a better architecture. It's easier to implement those services independently from each other. There can be a team dedicated to each service. You can potentially scale and monitor independently those services. So for example, you know that one particular service is going to be used way more than the other services, then perhaps you're going to attribute a bigger box, a bigger server to serve that service. It's fairly easy to implement because it's just a service call, whether you're using REST or potentially other approaches like gRPC. In terms of cons, well, as I said with our example, there's quite a strong coupling between the services. So each service can become a point of failure in the overall business process. And what about error, retry, timeout logic? How do you handle those? You'd have to handle those at each point where you call those other services. So there's all this logic, which is not business logic, that is part of the code of your microservices. So this is not ideal as well. And also, who ensures that the whole business process is successful if something fails in the middle? So it's not yet perfect. So another approach would be to go with a choreography of events, an event-driven approach, where instead of having services call each other in a sequence, you'd be using some kind of message hub, message broker, something like a publish subscribe mechanism, where actually the front end is going to send an event, a message to some message broker. Then the payment processor might be able to pick up that message and react to that event, and in turn send other events that other services will pick up from the message bus. So this is interesting, but because there's less coupling, it's not the responsibility of each other service to call the other services. It makes things more reusable and potentially more scalable, as you can scale independently those services. So imagine now something a little bit more complicated in an event-driven scenario, where this time, instead of having a sequence of services, you'd have more branches and conditionals and third-party or external services or systems that you need to call. So for example, here, let's say you're going to check in your inventory, in an external inventory database, that the product, the user, the consumer wants to order, is it out of stock or not? So you might have two branches. One where you need to call your supplier API to replenish the stock and update the inventory DB, or on the other branch, it's all good and you can prepare the order. And then, okay, you can also update again the inventory database to say, well, there's one item less because you're preparing the order. And you can also use a notification service that's going to point to some external service like SendGrid and other similar services. You may want to handle situations differently depending on whether it's a big order or not a big order. And for example, you might want to involve your sales rep and touch base with the sales rep via the Slack API if the team is using Slack for that. So what happens with those messages flowing around? It's usually harder to really figure out what's going on. And what's the exact business process that is followed along this more complex scenario. So again, pros and cons here. So pros, services are loosely coupled, so it's easier to implement, to scale, to develop. You might have teams working on each service independently. And the big, I don't know, perhaps the shipping service is the most complex one. Perhaps you're going to need bigger boxes, bigger teams to work on that one. There's no single point of failure because you just react, each service reacts to the events, the messages that they are interested in. And another nice aspect of event-driven architecture is the fact that it's rather easy to extend the system in the sense that, for example, you introduce a new service, maybe it's going to subscribe to an existing event. So it's going to be notified along with other services of a particular event, or you may also add new events and your service, your new service or existing service could subscribe to that new event. So it's fairly easy to extend the systems. In terms of cons, as I said, for more complex business transactions or business processes, it's harder to monitor the whole system because it's complicated to figure out, okay, this is this event that actually triggered all those other service invocations or all other messages are really coming from the fact that there was this first event that was triggered and generated in the first place. Things like errors, retries, timeouts are also a bit complicated because since it's not service to service call, it's not at the service calling the other service that it can define such policy. So it would rather be at the level perhaps of the pub sub topic or something like this, where you can specify such details like should you retry if the message delivery failed or not. The other downside is, or think of it when you've got a new member coming into your development team, like they want to understand what's the actual business flow, how the events are flowing, what event is going to, which event is going to trigger which other services. So since there's no description, there's no file describing how those interactions are going to happen. So this business flow is not really captured in an explicit manner and can't be versioned or put into, source control. And overall, who ensures that the whole transaction or business process is successful? Because, there are events flowing around, but there's no concept of an overall transaction, because the behavior of the overall system for one particular business process is emerging out of the flow and handling of events. So it's not necessarily clear when or not it is successful. So I'll hand over to Mete to speak about the orchestration aspects.
All right, let me share my screen. All right, so thanks, Guillaume, for the introduction to event-driven systems. So as you've seen, when you use service-to-service calls, it's easy to implement, but then you have this tight coupling that you don't want really. And then you switch to event-driven systems, then you get the flexibility of event-driven systems, and it's easier to extend these kind of systems. But then that comes with the complexity of event-driven systems. So you need to deal with multiple events. You need to figure out how to ensure the transaction is successful, things like that. So it's not perfect either. Now, another approach that you can take is what's called orchestration. And if we go back to our previous simple example of the e-commerce transaction, in the orchestration approach, what you can do is that first, you still have a front end receiving the request, the order request. But instead of calling the next service in the chain, or instead of sending a message to a message broker, the front end can start an orchestration. And this orchestration typically happens in an external service. So you have an external orchestrator where you define how the orchestration should happen. And the orchestrator will make the calls in the order that you defined. So in our case, the orchestrator will make a call to payment processor, passing in the order details and get it processed. Then when the payment processor returns, if there's an error, the orchestrator can retry. But if there's no error, then it will pass the details to the shipper, and so on and so forth. By the way, another approach here is that instead of having orchestrator externally, you could kind of act like orchestrator is part of the front end and let the front end drive this. That also could work, but I don't recommend that, because you don't want to mix your front end logic with your orchestration logic for many reasons. So usually it's better to have an external service doing this orchestration. Now, the pros and cons of this approach is that, first of all, since you have a central place doing the orchestration, you can capture your business flow in a central way. And since you can capture it, you can version this business flow. You can check it in Git, and you can have multiple versions that this deployed, and you can go deploy a new version or roll back to the previous version. So there's a lot of benefit of having this flow captured centrally, and we'll show you an example of this later in the talk. In orchestration, you have this notion of steps. So there's steps and things happen in each step. And because everything is broken into steps, if something fails, it's very easy to see what failed. You can just look at which step failed, and then see what's happening in that step, and then go to that service and then look at the logs of that service. So tracing becomes easier. The errors, retries, and timeouts that we mentioned before, now you have a place to centralize them, right? You probably want to have some kind of error policies, right? So if a service fails, you probably want to apply a number of retries, and you probably want to do these in a exponential backoff kind of way. So all these policies that you want to apply centrally or in each service, now you don't have to implement them in each service. Instead, you can implement them as part of your orchestration. And one of the nice side effects of orchestration is that you can stick with simple HTTP calls. So you can stick with simple REST calls without having to deal with eventing and all the different event formats that comes with eventing. So this tends to make things easier. And your services are there, they're still independent. So we're still dealing with microservices that are doing one thing at a time. They're deployed separately, they're scaled separately. but you're creating what I call a temporary monolith, basically, with the orchestration. You put microservices together temporarily in this orchestration and make sure that they act like a unit, but under the covers, they're still independent services. So you get the best of both worlds, where you have the independent services, but at the same time, you get this cohesive unit that you need. On the other hand, an orchestrator it's a new service that you need to learn and maintain. And we'll talk more about this later when we talk about Google Cloud Workflows. Orchestrator could be a single point of failure. So if your orchestration service fails, your whole chain fails. So you need to make sure that you're using something that's resilient and reliable. You are ultimately losing the flexibility of eventing, right? So if you want to extend your process and you need to include a new service, for example, it's not as easy as plugging in the service and figuring out like what kind of events it's interested in. Now you need to plug in the service, but you also need to change your orchestration and deploy a new orchestration. So things become a little bit less flexible. But that's kind of the point of orchestration, is that you want to make it a little bit less flexible. And you still need to have this problem with transactions. So now you can see if the transaction fails very easily, because you will see that a step failed in your transaction, but you need to worry about how to compensate for the transaction or how to compensate for that step that failed. For example, if we are looking at the payment processor, if the payment failed, then you need to have another step to compensate for that, and maybe give the user, if you charge the user already, maybe give them money back or something like that. So you need to have these compensation steps in your orchestration. It doesn't come for free. So the transaction becomes easier in the sense that you see what failed, but you still need to decide how to handle those failures. So in terms of which one should you use, choreography, orchestration, which one is better? And as in every software engineering problem, it really depends on what you're trying to do and how much flexibility you want and how much structure you want in your architecture. But there are certain things that I look for when I'm trying to design an architecture. And these kind of guide me whether an event-driven system is better or whether orchestration is better. And these things are, if I have services that are not so closely related, meaning they don't really need to know each other, they don't really need to call each other in a certain way. And if these services, they can exist in different contexts. For example, if you have a notification service, and this notification service can be part of an e-commerce transaction, but maybe it can be part of some other transaction, right? So if you have services like that, usually event-driven architecture makes sense, because you want these systems to be plugged into different contexts, and in event-driven systems, this is easier to do. On the other hand, if you have services that usually go together, they're usually deployed together, and they usually have a certain order that they need to be called in, then that's when I start thinking orchestration, especially when you can define your architecture in terms of a flow chart. If you remember, Guillaume showed a more complex transaction with database and third-party calls and things like that. So when you look at that transaction, it's a little bit complicated, but you can, when you look at the flow chart, it's very obvious what should happen, in what order, and what are the branches and all that kind of stuff. So if you want to preserve that logic, then orchestration enables you to do that. You can actually define it strictly in a YAML or JSON or whatever, and preserve that and version that and things like that. And also, I put this in parentheses, but with event-driven systems, you have events, multiple events, and multiple event types, and that implies that you need to have a way to emit those event types and also parse them in your code. So this usually results in a lot of complexity for your applications. If you want to stay in pure HTTP REST, then orchestration and orchestrators usually help for that. So I wouldn't say you choose orchestration because of this, but it's a nice side effect that you will have if you choose orchestration. And also, you can take a hybrid approach, right? You don't have to choose one or the other. For things that make sense to orchestrate, you can put them in an orchestration, in a bounded context. And then once this orchestration is done, it can signal to other orchestrations using messaging. So in this case, things that make sense, they get into an orchestration. And then if you need to continue with some other orchestration, they can signal each other in a more loosely coupled kind of way. All right, so this is a quick overview of choreography versus orchestration and when to use what. Now Guillaume will take over and he'll tell us what kind of tools and services exist in this landscape. Guillaume, you're mute.
There are a couple of questions that popped up in the chat, so I'll read it aloud. Can the orchestration service be deployed as multiple instances in parallel to prevent the single point of failure? So the product we'll be showing is that we used in our demo application, our case study later on. We've been using Google Cloud Workflows, so it's a globally available system. So there's just one such instance that is deployed and is serving all the workflow and launching all the workflow executions. So it's you should trust. So it's not just, we will mention that in the landscape as well. The other cloud-based actors in this field also have usually the same approach, which is a global service, and you usually trust the cloud provider to have only, well, to have a great SLA for this service. That said, just last week I was discussing with architects from some big banks and institutions in France, and we were chatting with the fact that when you use solutions like, I remember one of the person I was talking to was mentioning they were using JBPM, for example, for their business processes. And they told me that they tend to actually deploy the workflow engine along with the workflow within a container, and they scale containers on their compute infrastructure. So it's also another approach when you don't have a global central system that you can use. So both approaches are possible. And the second question, can orchestration also be achieved to make the orchestration service respond to domain events instead of using REST to control the orchestration process? Yes. So for example, with workflows that will be the workflows product that we'll be showing in a moment, you can also interact with PubSub, for example, the PubSub service and message broker, and you can receive and send events. So it's not just about REST API that you can call and interact with. So yes, it's possible, although the way we implemented it in our application that we will be showing you in a moment, we were using REST to control and call those services. All right, so let me share my screen to tell you a little bit about the landscape. Sharing, and it should be appearing, yes. So in terms of landscape, the major cloud providers provide solutions for choreography for event-driven architectures. So on AWS, there are different services and queuing systems. On Azure as well, like a service bus or different event products. On Google Cloud, we usually use PubSub as a publish subscribe mechanism to exchange messages. We also have even Arc, which is an interesting product and fairly recent product as well, which allows you to create bridges between events and services currently hosted on Cloud Run, but we're expanding this. And it reacts to tons of, I forget the exact number, but tons of sources of events from within the cloud and your cloud project. There are obviously some very interesting open source projects that you can take advantage of. The previous presentation was talking about KSQL-DB that was based on Kafka. Kafka is probably one of the most used open source solutions for exchanging messages. Pulsar from the Apache Foundation, etc. We also have, for the orchestration, each of the cloud providers have solutions, step functions for AWS or logic apps on Azure. On Google Cloud, we have two products. So there's workflows that we're going to use in a moment, But there's also Cloud Composer, which is based on the Apache Airflow open source project, but it's workflows more for data-driven pipelines rather than business processes, right? So it's a different angle to orchestration. And although, yeah, it's not mentioned there, but there are other products for orchestration, like I mentioned, JBPM, like Camunda, etc. There are existing products for this that you can deploy and potentially have different instances for those orchestrators. We also, I'm not going to go into each line and column, but we did a little study of the cloud providers and their main orchestration product. So both have more or less the same coverage in terms of features. And some are also, for example, the last column here, there's a bit more red in the Google Cloud workflows, but for example, those ones are features that are currently being worked on. So we'll be turning green soon. And I've got a second screen there as well. So since we're sharing the slides, I will already share the link in the chat. You can have a closer look if you want to dive deeper and see what's important for you. If you want to, better understand what's going on there. The other thing I'd like to mention, so it's still fairly new, but you should keep an eye on this. It's the CNCF Foundation and its serverless workflow project. So it defines a specification to describe workflows, whether it's calling REST services or event-driven architectures. So it provides a DSL to describe this. There are SDKs for different programming languages. Hopefully some of the providers and products that are implementing workflows will hopefully at some point implement this specification. The other thing is that it's using the cloud events specification for describing the events that are exchanged, and also open API for describing the REST APIs that are used for calling services. So it's something to keep an eye on. So I'll hand over again to Mete to tell us more and zoom in on Google Cloud Workflows.
Yes, thanks. And before I continue, someone asked a question. So how would you mimic the cloud workflow in a local environment? And that's a good question. As of today, there's no way to run workflows locally. But it's something that we raise with the development team, and it's something that I think we should provide support at some point, I'm hoping. But as of today, there is no like local emulator version of cloud workflow, but it's something that we're aware and we want to provide for people, because it's important when you're developing locally to be able to run it locally, maybe from your tests, stuff like that. But I should also mention that deploying to workflow and running workflow is really quick. So what I usually do is just change it, deploy, run, and then see the result. I know it's not ideal because it's not local, but at the same time, it's so quick that I don't usually care at this point. But the point is taken that local development is important. So it's something we hope to provide.
And just as an addendum, perhaps since between the parentheses, they were also mentioning orchestration. For example, if you're using PubSub, there is an emulator for PubSub, but not yet one for workflow. And the other thing, perhaps you should think also in terms of integration tests and having different environments, like your testing environment in the cloud and your production environment. So you can test and deploy your workflow definition in test environment rather than check how things are working or not, and then deploy in the production environment later on. But yeah, it doesn't replace local emulators and for unit tests and that kind of thing. Yeah.
Yeah, and then as a follow-up, the question, there is also a question on how would a developer approach a workflow-driven architecture when working on a single piece of the system, and also in choreography. Well, first of all, when you're working on an event-driven system, the beauty of it is that you don't have to worry about what else is happening. So all your service has to do is figure out which events I'm supposed to read and read that event. And then at the end, figure out whether I should emit an event, and if so, which type, or maybe you shouldn't emit an event. So that's all you need to worry about, because anything else that happens is not your concern. On the other hand, when you're working with a workflow-driven architecture, your service needs to know, again, how it's going to be called from the workflow and how it's going to respond to the request. But you also need to go to the workflow definition and make a step that calls your service and gets the result and parses the result. So there's two sides to it. It's now at this point, you're not thinking about a single service per se, but you're more or thinking like a service that's part of an orchestration, and there's two parts to it that you need to deploy and change. Okay, so that's, I think, the difference. And the last question is Apache workflow not an analog? I don't know, what do you know what the question is, Guillaume?
Yeah, Apache Airflow, which I think is used by Cloud Composer. So I think it's more for data-driven pipeline, as I said, and less for business processes, calling, computation-based microservices, as far as I understand it, although I haven't used Airflow myself.
Yes, that's my understanding as well.
Yeah.
All right, so let's continue with Google Cloud Workflows now. So what I want to do here is that I want to quickly go through what Google Cloud Workflows provide for you, just to give you an example of an orchestrator and see what kind of things you can expect from an orchestrator. And then this will lead us to our case study, where we'll talk about a real application that Guillaume and I wrote, initially in an event-driven way, but we changed it to use orchestration. And we were pleasantly surprised, and we learned some things along the way. So I think we'll get there in the end of the talk, and I think it's very useful things that we learned. But before we get there, I want to basically first give you an idea on what Google Cloud Workflows provide for you. So what is Workflows? Workflows, it's an external service, well, Google Cloud service that helps you to orchestrate and integrate basically services and APIs. What you can integrate is your code running on Google Cloud, typically serverless compute on, for example, on Cloud Run to run containers, App Engine for applications, functions for Lambda-like functions. But you can also include other things like VMs, for example. If you have a VM with a public API, you can include that in your orchestration. You can include Google APIs in your orchestration. So any kind of Google Cloud API, like Vision API, BigQuery, or any Google API like Gmail, for example, as long as it's publicly accessible, it can be part of your orchestration. And further, you can include external APIs. So if you need to call SendGrid or Twilio API or something like that, you can include those in your orchestration as well. I like this approach of workflows because in a typical application, it's never about your code just running in a server, right? It's typically about your code that calls some APIs that might be in Google Cloud or not, or maybe it's calling some external APIs, right? So it's usually a combination of all of those, and Workflows allows you to bring those all together in an orchestration. Now, how do you define this orchestration? There's a Workflows definition language, and you can define it in YAML or JSON. Here I'm showing a YAML example, and if you go back to our previous example or our e-commerce application, we had a payment processor, shipper, and notifier running on Cloud Run, so a container and a Cloud Function. What you can do is that if you want to make this call in this order from the orchestrator, you create what's called steps, and you can call your steps anything you want. So in this case, we are creating a step called process payment, and then we define what happens in this step. Here we are making an HTTP post call. This is calling a Cloud Run URL. And we are passing in a payment detail that we received from the previous step. And this call will be made by Google Cloud Workflows. And then the result will be saved into this process result variable. Now, in the next step, ship items, we make another HTTP post call, but this time we are calling a Cloud Function. And then the input, the body is the process result that we received from the previous step. So we get the body of that. So you can see that we are doing a little bit of JSON parsing here, and we're passing that as an input of the HTTP, the body of the HTTP post. So you can see that here, like we define the steps and we define what happens in each step, and we capture the results and we pick the parts of the results that we want. So this is step sequencing that you can do very easily in Workflows. You can do things like serverless pause. So for example, maybe after you ship your item, you want to wait a little bit of time before you call the next service. So you can insert like a wait in your steps, and Workflows will wait for you. And then as I mentioned, you can pass JSON between steps. So you can read something here, get the result, then parse the result, then get the part that you need and pass it to the next step. So stuff like that, it can be done within the workflow, within YAML, without actually having to write code to do it. In terms of errors and retries, you can apply errors and retries at each step. So for example, you can say, I want to call payment processor, but I want to make sure that if something is wrong, I call it maximum 5 times, just to make sure that maybe the next one will work. And when I'm calling it 5 times, I want to make sure that I don't overwhelm the service. So I want to do this in an exponential backoff kind of way, right? So you can define this as part of your workflow step instead of doing it in the code. Similarly, if you have branching, like for example, let's say you shipped an item or you want to ship an item, and the shipper is successful. It says, okay, I shipped the item. Then you want to get the HTTP success code and route that to a notifier service to let the user know that their item is shipped, right? So you can do that in workflows, or you can look for other HTTP codes that are error related and send it to another service called pager to let the escalation, to let the support know that there's something wrong, right? So this kind of branching, usually we do that in code. Now we can kind of just let your shipping code do the shipping part of the job, but deal with the errors and success in your orchestration. And it kind of helps to see this in orchestration rather than inside the code. And you can also do conditionals and third-party calls. So for example, if you need to read a DB and check a value to see if something is in stock or out of stock and do different things, you can do this check within workflow itself, within YAML, so you don't have to write code for that. Similarly, if you have things where you need to call third-party APIs, like getting the order from a third-party supplier, that's very easy to do, just another HTTP call from workflows. And finally, just to wrap it up with workflows features, you can create sub-workflows. So these are workflows that you want to be able to reuse from multiple workflows. You can kind of encapsulate them and call them from multiple workflows. We have connectors to Google Cloud Services, and these connectors, they basically enable you to call different Google Cloud services, and they're very useful, more useful than you might think. For example, let's say you want to create a virtual machine on Google Cloud, and you want to wait for that virtual machine to start before you finish your orchestration. Now you can do this yourself, but it will involve multiple steps, because first you need to create the virtual machine, then you need to create some kind of a loop in your orchestration where you check whether virtual machine is ready. And if it's ready, then you finish your orchestration. If it's not ready, do you wait? Or maybe it throws an error at some point, you need to handle that, right? So there's a lot of things that you need to do. It's not just creating a workflow, creating a virtual machine. Whereas you can use Google Compute Engine connector. And with this connector, it does all this work of creating and waiting and checking for the errors automatically for you. So it makes it much succinct, basically, than you having to do it yourself. And we have things like iterations where you can make a call to say like Twitter API, get the results and act on the results in a loop with iterations. Or we can have human in the loop kind of orchestrations where the orchestration waits for a human to call back to continue. This is useful for kind of validation kind of workflows where you want a human in the loop. And to deploy a workflow, you basically first define your workflow and just deploy using G-Cloud. Then once it's deployed, you can execute it like this, and then you can see the execution here. And all of this is also visually possible. So if you go to Google Cloud Console, you can see your source. So this is your workflow definition. You get a nice visualization of what's happening in your workflow, which is very useful to visualize your workflow. And then you can edit and execute and see the logs and all that kind of stuff. Hopefully we'll have time to show you one in the next part of the talk. All right, now I will hand it over to Guillaume to talk about our case study, our Piccadilly application. You're mute.
As usual. And we have actually a few more interesting questions from Marwan. Steps ordering is captured in the declaration file because all the steps are going to be, so it's a sequence of steps unless you specify that you want to go to another step with branching. So you're going to say next is going to be next step 43 or whatever. So you can define this. Parallel steps, yeah, we're currently working on this. So it's hopefully going to be available in the coming weeks or months, perhaps month, but likely definitely before the end of the year, to have different, so parallel branch might be different branches doing different things in parallel, or branches doing the same thing in parallel, but on different sets of, or different data sets. How to deal with service in-out transformations. Yeah, so for example, Mete mentioned that you can access the JSON of the body of the previous service that was called. So there are a few built-in methods and functions that you can use to find the right bits of information from the JSON payload. But if it's a complex data transformation, it should probably live inside another service that would be responsible for doing that more complicated data transformation, because ultimately the workflow definition is about orchestration, but it's not about computation. So if you need advanced data transformation, you'd better externalize that into a dedicated service. Last question about authentication supported. Yes. So for example, especially when you're using services that are hosted on Google Cloud, it's very declarative. You just say use OpenID Connect, use OAuth2, and thanks to the magic of service accounts, roles, etc., it's handled for you automatically. And you can also, when you call a service, you can specify like a bearer token and that kind of things when you're calling external services. So let's hope we have enough time to go through our case study, but it's great to have all those great questions. Thank you for that. So we have a little application. It's a photo sharing application. I'm going to show you quickly where you can anonymously share pictures, see the latest collage of the most recent pictures. There's a form where you can upload new pictures. And here you can see in the main screen that there's for each photo, you can see the labels of what's been recognized in the picture thanks to machine learning vision API that we used. Same thing for the colored border. So we built this application first in an event-driven manner, but we then rewrote it using an orchestrator. So here we have the architecture where users in the front end upload pictures through that front end, and the pictures are going to be stored in cloud storage bucket. That's an event that's going to trigger various services. We're going to call a cloud function that is going to call in turn the vision API to analyze what's in the picture. We're going to store some metadata about the results in Cloud Firestore, which is a document-oriented NoSQL database, which is serverless too. There's a service that is called on a schedule, so not triggered by this new file coming into cloud storage. But the thumbnail service that creates thumbnails of the high resolution pictures is called also or subscribe to the event of a new picture that is saved in the bucket. And we have other events, for example, deleting a high resolution file will trigger another service using the event arc product and cloud event specification. And this one is going to remove the thumbnails and the metadata in the database. So we built this application in an event-driven fashion, but we noticed that because of the nature of the products we're using, for example, there's a event integration directly in the functions framework that we use when we deploy functions on Google Cloud Functions. So events are available directly as parameters. But for example, when you use a Cloud Run service, it receives HTTP requests. So if you want to get a file event stored on cloud storage, this event is going to be wrapped into a pub/sub message that is going to be wrapped in an HTTP request that is coming. So we have a different way to handle this message, although it's pretty much the same actually. And when using event arc, which is our bridge solution, we're flicking. It's going to use the cloud event specification, and it's again a different way to handle events. So you've got 3 ways to handle events, which is kind of weird. But Mete will tell you about the other approach that we created using the orchestration approach.
Okay, yeah, I will be real quick here since we are running out of time.
Yeah.
But basically, we took event-driven that was getting out of hand in terms of tracing what's happening in the system and rewrote it using workflows. And this is what we ended up with. And then when you look at this initially, you might think that this is actually more complicated, but all these services that I have in the boxes, they're part of workflows. It's one service, right? And the idea here is that we still have the same kind of flow where the user uploads something, it goes to the storage bucket, and then that triggers an event. But after that, instead of doing other events and getting services, getting events, we start an orchestration. And in this orchestration, we check the event type. And if it's an object deletion, we delete the object directly from the workflow. And then if it's a new object, new image, then we do image analysis and check whether the image is safe within the workflow. And then we store the metadata again within the workflow. And then we make calls to the thumbnail service and collage service. So here we are making external calls to these services. And here, the unique thing here is that some of the stuff is happening within the workflow, within YAML, for simple things like checking the event type, checking if the picture is safe, or things like that. But more complicated logic, like the creating the thumbnail or creating the collage, is happening by calling the relevant services. So in that way, we can kind of mix and matching what happens within orchestration or within external services. So I'll just pause here. I won't show you the app or the orchestration because we don't have time, but I think it's important to talk about lessons learned. So maybe Guillaume, you can tell us what we learned by doing this transformation.
So let me show you this. So quickly, let's go through those lessons that we learned along the way. So what was interesting in this rewriting was that it was pretty refreshing to go back to a simple REST approach instead of the 3 eventing formats and handling of those events. So that was quite nice to have one consistent way of calling those services. We also had less code because there's no even parsing. It's just, well, JSON payload parsing. And also we even got rid of some of the services or some parts of the code that we had in some of our services. And even one service vanished away because we were really just doing API calls, declarative API calls. Since they were really declarative, we could use put that declaration in the workflow definition itself instead of having just code doing this kind of just dumb API call. So that was nice. The other aspect was that in our architecture, event-driven architecture, we were using PubSub, a cloud scheduler for doing things on a schedule, event arc to a bridge for events to some services. So we had different products or services to set up to create the topics, etc. So there was quite a bit of setup, whereas here we just handle things in workflows or when we were deploying each and every service. In terms of error handling, it was also easier because that, again, was done declaratively in the workflow definition. So it was simpler. And even if you had, well, that wasn't the case, but if you have one service that is called several times, you could have different error handling logic depending on the bounded context or the business process. And some less positive aspects were the fact that when we started this rewrite, workflows wasn't released yet, so it was still lacking a bit of documentations and samples, etc. But that's also our job to help with this. So fortunately, now it's much better than this was when we started. It was, you know, as I mentioned in one of the questions in my answer, so a workflow definition is not about coding inside a YAML file, right? So it's really declarative approach to call services or to branch through different branches of your business process, but it's not about coding inside a YAML file. So be sure to not put code into a YAML file, because it's harder to test, harder to debug, etc. And also YAML definition. So you've got some IDE support for, the syntax of YAML, but you don't have as much support as you would have when you code something. So especially for code things. Last aspect, perhaps a bit of a loss of parallelism or even flexibility. As we said, it's easier to extend an event-driven architecture usually, whereas here you would have to retest your workflow definition when you extend and add new services and new events. So that's about it. Thanks a lot for attending this presentation. Here are a few links you might want to check out with getting started guides, some code labs if you want to get your hands on these things. And also be sure to reach out to us via Twitter, for example. If you have some further question, we'll be happy to answer these questions. So thanks again for your attention.
Thanks, everyone.
Thank you.